Welcome once again, friends. Today we are going to discuss question number 4, exercise 13.1, surface areas and volume, class 10th maths. The question goes like this: a cubical block, a solid cubical block of side 7 centimeter is surmounted by a hemisphere. Uh, how does the figure looks like? Let us draw the rough sketch of the figure. This is your cubical block. Okay, this is your cubical block. Okay, how many faces does it have? 6 faces does it have. What is the length of each edge? That is 7 centimeter, 7 centimeter, 7 centimeter. Each of its edge measures 7 centimeter. Now on the top of this cubical block a hemisphere has to be mounted. Mounted means to be kept. So, but the condition is, what is the greatest diameter? We have to mount a hemisphere in such a way so that the diameter of the hemisphere must be the greatest one. It means this will be only possible if the diameter of the hemisphere that is to be mounted on the top must be equal to the edge of the block. So you can see from the figure, this is the diameter and this diameter is equal to this edge. So we have mounted a hemisphere in this way. Okay, so this is your hemisphere. So this is a rough sketch. I hope you can get the you can visualize the solid figure. Now the question is, first part is, what is the greatest diameter? So of course the greatest diameter is the edge of the cubical block, that is 7 centimeter. From here we can easily find out the radius of the hemisphere that has been mounted. This will be half of the diameter, 7 upon 2 centimeter. Okay, the first part has been done. Now come to the main part of the question. We have to find out the total surface area of the combined solid figure. Surface area means here the total surface area. Now from the figure you can easily see that out of 6 faces of cubical block, the 5 faces are clearly visible. So we must have we must have to find out the area of the 5 faces. The 6th face where the hemisphere has been mounted, that has to be studied carefully. Okay, so let's begin in the first page. So B part, we have to find out the total surface area, or in short we can write surface area of the solid. So this has to be find out. Now in the first page I had shown you that in the cubical block we have 5 faces of the block clearly visible. There is no doubt in that. So each edge was your 7 7 7. So the area of 5 faces is your 5 into a square, if suppose each edge is your a. So for 5 faces, bottom, left and right, front and rear or the back, there is no such problem. The problem begins with the top face where the hemisphere has been mounted. Now the hemisphere has been mounted in this way. This is your hemisphere. This we have visualized. Now the 5 faces have been done. Now come to the 6th face and the hemisphere. From the figure it can easily be concluded that the curved surface area CSA of this mounted hemisphere has to be included in the total surface area of the combined solid. It means plus we have to add CSA of the hemisphere. CSA of hemisphere. Now are we done or not? If you carefully look at the figure, we are still not done. Why we are still not done? You can check out this left out corner area of the corners. Here also there will be a area, here also third corner, and in the fourth corner these area are also left out, and we have to include these areas. But what about the innermost region that has been innermost circle that has been covered by this hemisphere? You must have to keep in mind this innermost circle area is not visible to us. It means that area is not to be included in the total surface area of the combined solid. It means here we will have to only include this portion, corner portion, second corner portion, third corner portion, and fourth corner portion. The question arises here is how to find out this four corners area. Now this can easily be explained if we look at the top view of the solid figure. How the top view of the solid figure will appear? Just try to visualize. This is your top face of the cubical block, and on this top face a hemisphere has been mounted in this way. This is the base of the hemisphere. Now you can easily see here that these four corners are left out, and we have to find out these four corners. Why we are not finding out the area of the central portion? Because the central area has been covered up by the mounted hemisphere. So this area will not be visible to us, and we cannot touch this area. That's why this area has to be excluded. It means we are concerned here only about this area, this area, and this area, and this area. How to find out these four corners area? Very simple. We have to subtract the area of this circular portion from the area of this whole cube. It means here, so we'll have to write that is cube area is your a square, because a we are having edge, and the area of the circle is that minus pi r square. So finally we have got the formula, that is 5a square for 5 faces, and CSA of the hemisphere we all know, this is your 2 pi r square, and here the area of four corners, the remaining four corners, is a square minus pi r square. So ultimately here we got 5a square, 6a square, and 2 pi r square minus pi r square is your plus pi r square, because we have here 1 pi square. Now 6a square and pi r square. 6 and a square is 7a square, because the edge is given 7, pi means 22 upon 7, and r, that is this is the diameter, and this is equal to 7 because edge was 7, and half will be your 7 by 2 r square. So the calculation will keep on going like this. This is your 7, this is your 49, and this is 22 upon 7. So 7 upon 2 square means 2 times you have to write 7 upon 2. 7 gets cancelled out, 2 and 22, it will become 11 when these two get multiplied. 6 9 are 54, so, and 6 4 are 24, and 5 is 29. So here we have 77 upon 2, this cancelled out, 3 8.5, and when these two added we'll have 0.5, and then 2 3 and 3. So this is the area of the combined solid, that is cubical block, and the hemisphere mounted on the cubical block. I hope you enjoyed the video and understood the complete solution. If you have liked the video, do subscribe, like, share, and do comment. Wait for the next video. Till then, goodbye and take care.